Hello, hello. I hope you are doing well. We are going to listen to podcast number 3, which is on limiting reactants. So need to find this place in your notes. And limiting reactants is something that many companies all the time are taking a look at. They do not want more raw materials than what they need to purchase and what their output is going to be because they want to maximize their profits. Now, this is just a really simple little supply and demand example that you can see I have 20 slices of bread, 24 slices of meat, and 12 slices of cheese. And to make a sandwich, we need 2 pieces of bread, 3 slices of meat, and 1 piece of cheese. So how many total sandwiches can you make? So what you want to take a look at is if I see that I need 2 slices of bread for each sandwich, then that means I can make 10 sandwiches with that. 24 divided by the 3 slices of meat, I can make 8 sandwiches with that. And then I can make 12 sandwiches with my slices of cheese. So how many total sandwiches can you make? Well, I can't make more than I have of other ingredients, so I can make 8 sandwiches. And what ingredients are going to be left over? Well, I'm going to use all the meat, so I'm going to have some bread left over, and I'm going to have some cheese left over. So how much of each ingredient will be left over? Well, if I take the 10 subtract the 8, that would be 2, but in each sandwich I have 2 pieces of bread. So essentially I'm going to have 4 pieces of bread left over. Do the same thing for the cheese. You can see I can take 12 subtract 8. So I have 4 slices of cheese left over and I only have 1 piece of cheese on each one. So I would have 4 pieces of bread and 4 slices of cheese. If I wanted to start again and make some more sandwiches, then I would have those left over. So limiting reactants are really important in all kinds of things, even in your body. We have to make sure that we have a certain amount of vitamins and minerals that we cannot get from anywhere but our diet. And if we don't have it, then whatever our body needs them for, it's going to stop producing. And so limiting reactant, we are fine-tuned machines. We need them in our bodies. We have limiting reactants kind of ideas in pretty much everything that we're doing. So what is it? It's the reactant that runs out first and thus limits the amount of products that can be formed is called the limiting reactant. So just like our sandwiches, we had that the meat was our limiting factor of how many sandwiches we can make. So the reactant that is not completely used up is called the excess reactant. So in our example, that would be bread and cheese. Now to determine which reactant limits the reaction, you must use our smiley face here, lovely stoichiometry. And so that's what we're going to start with. So if we take a look at our first reaction in example 1, you can see that we have 20 grams of sodium metal. So I'm going to have sodium metal reacts with 20 grams of chlorine gas, and hopefully you remember that chlorine is going to be diatomic and it is a gas. And this looks like it's going to be a synthesis reaction, so Na is +1, Cl is -1, so I get NaCl, and this is going to be in the solid form. And I need to balance this, so I need 2 chlorine here, 2 chlorine is on the left, I need 2 sodium here. Okay, so now I would go back and I would read what's given. So I have 20 grams of this reacting with 20 grams of chlorine gas. Now the idea here is that I have to see which one of these is limiting. Now the only way I can compare is in moles or grams, whichever way you want to go, but I have to go all the way to the product. And so this is going to be my X. I have to get the chlorine. I have to get the 20 grams of chlorine to be how much I can make of NaCl. I have to get the 20 grams of Na to see how much I can get of that. And then I will be able to answer questions about the limiting reactant, excess reactant, and all of those sorts of things. So my mole map on both of these is I can just essentially go from grams to moles to moles. You could go all the way to grams again if you want, but that's just an extra step that we don't really need to worry about. So I'm going to go from grams to moles, and I'm going to stop with both of these in moles of NaCl. Okay, so let's go ahead and start doing that. So the first thing I'm going to do is I'm going to take the first one, 20 grams of Na, and I'm going to say that in 1 mole of Na, I have 23.0 grams of it from my periodic chart. And then I'm going to take a look at my mole to mole ratio. Unknown is NaCl to 2 moles of Na. And so when I go ahead and calculate this out, I'm getting 0.870 moles of NaCl. Okay, so let's do the other one. We're going to do the same exact thing. I just have to bring that 20 grams of chlorine gas all the way to the same moles of NaCl. So I know that when I have 1 mole of chlorine gas, it's 2 times 35.5, and so that molar mass is 71.0 grams. And now I'm going to do unknown over known. So I have 2 moles again of NaCl to 1 mole of Cl2. And take a look at your units again. Grams of chlorine cancels out with grams of chlorine, moles of chlorine with moles of chlorine. And my calculation is going to give me 0.564 moles of NaCl. Now, only now can I take a look and see what my limiting reactant is, because I have both of my reactants, which are on the left-hand side, to the same product. So because they are the same, now I can go ahead and say that, well, this one right here, the 0.564 moles of NaCl is less, so then this starting material is going to be my limiting reactant. So that means that this chlorine right here is my limiting reactant. And a lot of times you'll see me circle it way up here in my equation. This is my limiting reactant. We're going to ask a series of questions, and these will become more difficult, but we are always going to go back to our limiting reactant to answer any questions. Okay, so that's the first one that I have here for you. We're just going to do example number 2, and then example number 3 I'm probably going to have to do on another podcast. This might get a little long. Okay, so example number 3. We have lithium nitride, an ionic compound containing lithium and nitrogen ions, is prepared by the reaction of lithium metal and nitrogen gas. Calculate the mass of lithium nitride formed from the mass of each one in the unbalanced reaction. Okay, so we can just go ahead and simply balance this. You guys can see with the nitrogen, I have 2 nitrogen on the left, so I need 2 nitrogen on the right. 2 times 3 is 6 lithium, so I need 6 lithium, and my nitrogen is balanced. Go back and read exactly what is given. So I am given, let's see, 56 grams of nitrogen and 56 grams of, this should be of, lithium. So I have 56.0 grams of this, and I have 56.0 grams of that, and I'm going to bring both of them here. This time I'm going to do it to grams so you can see the difference. And we have to find our limiting reactant by bringing both of them over to the product side. So I'm going to take 56.0 grams of lithium, times sign fraction bar. I know that I have 1 mole. Remember, I'm just finding the molar mass of plain old lithium, not the 6 in front of it. And let me see what that number is. So that would be 6.9 grams of lithium, times sign fraction bar. So I'm doing my unknown over known. I have 2 moles of lithium nitride to 6 moles of my plain old lithium. And then the last step will be to multiply by the molar mass of 34.7 grams of lithium nitride in 1 mole. Again, checking my units, I can see my grams of lithium cancels out, moles of lithium nitride, and my resulting answer then is going to be 93.9 grams of my lithium-3 nitride. Okay, so I'm just going to do the same exact thing with my nitrogen, bring it all the way to the end. So 56.0 grams of nitrogen, times sign fraction bar, I know 1 mole of nitrogen times its molar mass, which is 14 times 2, would be 28.0 grams per mole, times sign fraction bar, so my unknown is 2 moles of lithium nitride to 1 mole of nitrogen. Do my last thing, I'm using the same product again, so 34.7 grams of lithium-3 nitride in 1 mole. Okay, so then I'm going to check my units again, grams of nitrogen, oh, I put grams per mole, sorry, grams of nitrogen, and then moles of nitrogen, lithium nitride moles of that, and I have grams of the same substance. So when I multiply that all out, I get 139 grams of lithium nitride. So I look at both of my answers, and I can see now this time that my top answer is the one that is my smaller amount. I have less grams of this, so this is limiting my equation. So what started this? The factor was way back here. My 56 grams of my plain old lithium is my limiting reactant. So if you look back, you can see here that my last step is the same. So all I did is I multiplied by the same molar mass to get it into grams. If you go back a slide and look at this one that I did, I stopped at moles. Well, it would end up being the same exact thing if I multiplied again here by the molar mass. I'd be multiplying by the same molar mass. So if you like bringing it all the way to grams, that's perfectly fine with me. It doesn't matter. But stopping at moles does the same thing because I would be multiplying by the same molar mass anyway, so it's really not going to change your results, as you can see here. So I could have stopped right here and figured out my limiting reactant, or I can go all the way into moles. Okay, but the question that it asks in this one, this is the reason I did do that, it says calculate the mass of the lithium nitride formed. So how much can I form? And the final answer is going to be the 93.9 grams. So I can form 93.3 grams of lithium nitride can be formed. So I'm formally answering that question now. All right, that is limiting reactants. You've probably heard enough. You could go ahead and get started on homework 5. There is on example number 3 a couple of extensions. So you may want to start and then come back and listen to example 3, which will help you with homework 5. And you'll know at that point where you need to go because you'll get to some questions that you haven't seen yet. Okay, have a wonderful night and I will see you soon.